Let's put ourselves in the holy presence of God as we pray in the name of the Father, the Son, the Holy Spirit. Amen. Our Father, who art in heaven, holy be your name. Your kingdom come, your will be done, on earth as it is in heaven. Give us this day our daily bread, and forgive us our sins, as we forgive those who sin against us. Do not bring us to the test, but deliver us from evil. Amen. In the name of the Father, the Son, the Holy Spirit. Amen. Good afternoon, ma'am.
Hello, good afternoon, everyone. Thank you, Ma'am Pania.
Good afternoon,
So,
ma'am.
good afternoon. Okay na ta? Comfortable na mo diha sa inyong respective
Yes, yes,
locations?
ma'am.
Nakapaniud to na?
Yes,
Madadara
ma'am.
man mga
Wala dala. Magsinda na lang, sir. Sindan og paniud to. So, what time mo ni end ni Sir hinampas?
9, ma'am.
Sa'yo ra di ay. Hindi, bantog kay sa'yo kayo si Sir Rafael. Ready na ra ba si Sir? Sige, so it's already 1:53. I think we are now going to start with our first reporter or presenter. My arrangement here is alphabetical. However, if someone would like to volunteer, nga mo'y first nga mo report, welcome. Welcome ang mo volunteer. Kasi ganahan nga first mo share sa iyang answers for the first activity. If nobody would like to volunteer, can we start alphabetically? So we will start with Sir Manuel Ampak. Wala si Sir Manuel, dahil no?
Wa pa kasud siguro, ma'am.
Sige, so since wala pa si Sir Ampak, can we proceed to next to Sir Ampak is Ma'am Ampong. Can we start with Ma'am Ampong? Ready na si Ma'am.
Yes, ma'am. Good afternoon sa tanan. I-clarify lang na ko, ma'am, no, kami mo pili, ma'am, no, sa among i-present.
Yes, you are going to choose one subcomponent of theorem 1.10 and then another subcomponent of theorem 1.21 and for all the
1.23.
theorems but
Sa number
for
1 lang ko, ma'am. Ah,
yes, so you have the
okay.
option ma'am kung unsa nga specific example ang i-present nimo. Thank you.
Okay, sige, ma'am. Okay. Wait sa mama. Okay, bago pa po ko aning G-class, di kayo po anat pa. Wait, ha.
Sige ma'am, kanang na arrow you can click arrow ma'am. Okay.
Okay, then. Okay na ba ni ma'am? First, nakuha na ba ako ang wait,
Yes
ha?
ma'am, just kuan ma'am, direct to your slide ma'am. You are
Wait, lagi.
sharing your screen naman. Ay lang ng
Okay.
Facebook kay makabasa mi. Facebook among nakita
Hala,
for now.
sorry.
Pero wala
Hala,
man
ma'am.
okay na siya.
Wait, ha? Di pa, ma'am. Murag ani kita malangan na rin.
Ma'am, pwede
Wait.
nimo to i-open daan ang imong presentation.
Okay. Sige,
O
ma'am.
para
Wait, ha?
inag-screen share nimo makita ra dayon ang kadto nga page.
Pero makita na siya, ma'am, karon?
Yes ma'am,
Ano ko?
okay na.
Okay. So, di ko pakita ninyo, no? Okay, murag, pero okay lang makita mo sa akong presentation.
Yes
So,
ma'am, clear.
I will choose 1 sa 1.10, 1 sa 1.21, and 1.23. So, for 1.10,
For a while ma'am, sorry ha. Medyo dili clear akong instruction no. So sa presentation nato, you're going to present ay to choose from for a while. you're going to choose one example for theorem 1.10, 1.21, 1.23. For number 2, you're going to explain everything, ma'am. Pwede ra gud nga dili na ang detailed solution, but you're going to show example of
Sa
topology,
topology. Ah,
topological space, and example of open sets and closed sets. Larger
and
topology, and then for theorem 3.11, kadto pwede ra to i-show tanan, ma'am, kay there are only two results man adto, no,
topology o na
katong
topology.
intersection of the family of topology and union. So kanilang sa
Ah,
1.10, 1.21, and 1.23, you show only one kay daghan man ni siya
taas
og
na siya. Sa,
component.
sige,
Sige, ma'am.
sige, ma'am. Okay, so, um, 1.10. So, I'm going to show number 3. No, turag ani ko gamay nga confident po. If I will read to you, unsay sud sa number 3, if A is a subset of B and B is a subset of C, then A is a subset of C. That shows a transitive property, no? So, define na ko ang set A, set B, and set C. So, set A are ang yang components are vowel letters. B are the words or the letters that composes sa spelling sa Utopia. And letter C are the letters of the alphabet except for Q and R. To show that A is a subset of B, okay, so A is equal to the vowel, B is the letters that composes the spelling sa Utopia. So if you will try to get the subset A subset of B, A is a subset of B. It is because the vowel letters also belongs to Utopia. Then second is B, a subset of C, by which B, E, U, T, O, P, I, A, and C are the alphabet. Well, wait, sorry ma'am ha, kaya na-appeal man ako si Q o si R, supposedly kay ang akong explanation na to kay except Q and R. So, wala na sayo po ani, no? So, but, ato lang i-imagine nato nga wala si Q o si R sa ako ang set or sa element ni C. Still, B is a subset of C. It is because all the letters that belongs to Utopia also belongs to letter C. And C is bigger compared sa ato ang set nga B. And the last, we also have, therefore, if A is a subset of B and B is a subset of C, therefore A is a subset of C. So therefore, if we will try to recall that A are vowel letters and C are the letters in the alphabet, except for Q and R, that is first nga na-define na po sa ibabaw, no? Still, A is a subset of C because C is bigger nga alphabet compared to A. And all the vowel letters, bisan pag exact Q and R, still belong to the subset C. Next, theorem 1.2. In kanina lang, idempotent laws by which it states that the union of A are equal and also the intersection of A are equal. It is because kung say suits ni A, whatever will be the element of A, if we will try to i-union nato na, no, or i-combine, still equal to A, which is still for A, 3, 7, 8, 9, and 12, we will try to get the union of A still equal to 3, 7, 8, 9, and 12. So as the intersection, if we will try to intersect A to itself, still ang intersection is the element of A, which is 3, 7, 8, 9, and 12. Or simply, A union of A is always equal to A, and the intersection is also equal to A. For 1 point, sa ko, sa ba to? 1.23, Okay, for 1.23, ako saan kami yan ha? Yung warag na dako. 1.23, each of the following equivalent to a subset of B. If and only if A is A, intersection B will always be equal to B. And A union of B would also be equal to B. And B, okay. And B complement intersection of A complement. B complement would be a subset of A complement. Oh, wait. Pili na ko isa ni ma'am, no? 1.23. So, 1, 2, 3, and 4.
Yes,
Say,
ma'am.
I might show na lang number 3. That the B complement would be the subset of A complement. So, na-define na nako, no? That A is equal to 13579 and B is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So if that would be the case, B complement. When we say complement nung naatay universal, I didn't wala na ko gi-define ang universal, but then ako na lang siyang think that a universal is a combination ni A o ni B. So if you will try to think nga combination siya ni A o B, so a universal is equal gihapon ni B, which is 1, 2, 3, 4, 5, 6, 7, and 8, 9, 10. So if that would be the case, the B complement is empty. No? Empty CB complement kung magbase ta nga i-combine lang nato si A o B as the universal. C complement is equal to 2, 4, 6, 8, and 10. Then, the empty, the empty is a subset of A complement. Ang akong explanation ani ma'am is basically yes, because the empty are always the element of the subset to any set. But then, feeling na ho umurag naay kanang pwede mag-question ani no, bisag ako dili ko sure, pero as far as I remember, the empty sets are always a subset to any set. Okay, next. Topology. Topology and topological spaces. So my x is equal to 11, 12, 13, 14, and 15. My tau are empty x 11, 12, 13, 11, 12, 13, 12, 13, 14, and 15. It says nga a tau can be a topology if mo fit siya sa tulo ka condition. So first, if each union member of tau is a member of tau. So we have here union. So we will try to combine or i-union nato ang yung mga member. Una, union na po si empty nx, which is equal to x, which is an element of tau, or a member of tau. X and 11, which is equal to x, still member of tau. 11 union of 12 and 13 is 11, 12, 13, which is still, makita gihapon ninyo na still member of tau. 12, 13, 12, 13, 14, which is, union man, no? Sayo ko ani 12, 13, 12, 13, 14, 15, which is equal to 12, 13, 14, 15. Kanina ko an ko na, which is still a member of tau. Then 11, 12, 13 union 12, 13, 14, 15, which is equal to x, and x is still a member of tau. So therefore, all the unions of tau belongs to tau. Then ning-fit siya sa una condition. Second is each finite intersection of the members of tau is also a member of tau. So we will try to intersect all the members. No, wala na nako humanano, ay wala na ko gihurot sa tanan, so I just choose empty. The section of x is equal to empty. Still member of the tau. X, intersection of 11, 11. 11, that is intersection of 11, 12, 13, 11, 12, 13, intersection 12, 13, 14, which is still 12, 13, and all the intersection nga ako ang the member nga ako ang gi-intersect are all members of the tao nga akong define. Then the last uh, condition, if MT and X are the members of tau, and obviously member to siya. So therefore, the tao nga akong example is also topology. Next, B, we have open sets, closed sets, neighborhood, using the computed topology nga kani sa akong example. So open sets, as far as I remember, the members of the topology. So the member of the topology are MTX, 11, 12, 13, 11, 12, 13, 12, 13, 14, 15. Closed sets, sa ako ang na-remember, are the complement in every sa open set. Complement ni tawag aning empty x, complement ni x is empty, complement of 11, 12, 13, 15, 12, 13, 11, 14, 11, 14, 15, 11, 12, 13, 14, 15, 12, 13, 14, 15, 11. Then NBS of 11, neighborhood of 11 are members siya sa topology or sa tao na naa si 11. Sa 11 na siya ako ang pwede, any no, actually pwede ko doon, but then stop ko 11 na ko 11 belongs to X. Na put si 11, and then singleton ni 11, and 11, 12, and 13 sa larger topology. Nakoy tulo X, 11, 12, 13, 14. First, nako nga T, O, sanay siya, MTX 11, 11, 12. T1, MTX 11, 11, 12, 13, 14, 13, 14, 15. The definition of larger topology if 2A is a subset of T1. So thus, T1 is finer than TO. It is because mas dako or mas larger or mas many ang iyahang kanang saan siya? Sets compared to TO, and then TO is a subset of T1. Theorem 3.1 X 11, 12, 13, 14, 15 still. TO, gikopy rin ako ang larger typology, no? Ako ang example sa larger typology. We will try to get the intersection. Intersection, empty, intersection of T1 and T2. If we will try to intersect MTX 11, 12, 13. Matopology siya if ang members sa iyang intersection is also part of the topology. Topology ni 1 o ni 2. Then, not topology siya, T1 union of T2 is not a topology. Why? Because some members of the union of T1 and T2 doesn't belong to both tau 1 and tau 2. Mom, that's all.
Thank
Hello?
you, ma'am. Congratulations. Sige. So, I will give comments. But before sa akong
Yes.
comments, anyone who would like to ask or verify sa gi-explain ni Ma'am Ampong?
So much
Wala.
listening.
Wala mamugo. Sige, ako lang mo comment, no. Stop. Pwede na nimon siya i-stop screen share, ma'am.
Sige, ma'am. So to, okay, can we but to ma'am stop presenting again?
Sige, thank you, Ma'am Angeli.
Okay.
Okay, so comments, no. Mas easier gyud ay ko mag-report. Easier na ko makita ang inyong answers kung mag-report. Si ma'am po'y nakadetect mismo, no, katong na-include niya sa instruction. So, kuan ma'am Angeli sa theorem 1.10 number 3, kaning first nga solution nimo nga set A is 1, 7, 18, wala nilabot ma'am, no, 1, 5, 7, 18, wala siya labot. 1, 5, 7, 10, and 18, you replace it with another set, ma'am, no? Kaning naa
Yes,
sa right.
yes, ma'am.
Sige.
Okay.
So, kuan di ay, so far accurate man, no? Yeah, nakita man po to nato ang nakita naman po nato ang letter B, no? Unsay na include which is not supposed to be included in set C. Kadtong Q and R pero gi-correction na ni ma'am. Kuan, asa ko nag-comment ato. Here. Diri day sa kuan katong pag-show sa topology. So, general comments to everyone. Kanang when you are to show for a set to be a topology, ang atong ipakita sa solution is not just empty union X, but you show all other exhaustion of empty union other members of the set. So, empty union X, empty union 11, empty union the set 12 and 13, empty union 11, 12, and 13. Hantod mahurot siya, no? Kay mao man to ang way of proving na to nga topology ang set kung mo-hold siya sa
None.
tanang union if each union of the members of Tau is a member of Tau. So i-show to na to. If not, of dili na to siya i-show, pwede ra pod nga empty union X or empty union all other members of Tau is empty. So therefore, condition number 3 is satisfied sa atong solusyon. Okay na gud ni siya pero kanang sa exact way of presenting the solution ingatuon na to. Kung dili ta ganan nga i-show na to tanan, pwede ra i-istorya na to nga when you get the union of empty to all other elements of the set, it resulted to empty. So we can say that empty is in Tau. Yeah, sunod na po si X, union all other members of the set. So X union 12, but we can generalize kay we know nga when we get the union of X to all other members of the set, since all other members of the set are smaller than X, pwede po ta moingon nga X union all other members of the set or of the all other open sets is X for because of the fact that X is a bigger set among all other sets. So, mapashow na nato nga X is in Tau. Nga na siya. And so, with the finite intersections, so, i-show po na to, exhaust po na to tanan. Pero correct naman ang na-generate na to nga topology. And then, for 2B, kadtong showing the neighborhood, ang instruction ako kay neighborhood of X in X man, no? So, kuan. Okay man to. Okay tong gi-present ni ma'am, correct po siya tanan. Pero ang instruction lang nako kay X in X, so tanan pod atong i-show diri. Tanan nga mga X in X pasabot tanan nga mga elements sa X. So ang gi-present ni ma'am earlier kay X contains the elements 11, 12, 13, 14, 15. So i-show pod nato ang unsay neighborhoods of 12, 13, 14, and 15. Kana lang. And then theorem 3.13 by mathematical inspection, makita na to nga topology ang intersection and ang union sa two topologies presented here is not a topology. Pero kuan lang, late sa next nga mga activities pa nato, you justify nganong not topology siya. Pero gi-explain na ni ma'am ganiha sa hard copy lang, wala na suwat. As well as nganong topology man siya, same solution with the first item sa number 3. But in overall, the presentation of Ma'am Anjali is good, no? Unya correct ang iyang mga data. So thank you. Congratulations, Ma'am Anjali, once again.
Thank you, ma'am. Kubaan ko, ma'am.
Wala man, walay makitang kulba. Sige, some other comments from the rest? Wala na? Okay, sige. So we will proceed to the next presenter. Next presenter here is Sir Barrete. Nana si Sir Albert. After na lang ka ni Sir Barrete. After Albert, si Sir Ampak. Sir, there.
Hello, ma'am.
Yes.
Good afternoon.
Good afternoon.
Nagisod ko, screen share, ma'am, ba? Sa ako, kay nara sa cellphone. Ako sa ibalan, kayo sa laptop, ma'am.
Sige. Sige, sir. So,
Okay.
mo proceed sa ta sa other presenter.
Dapat ko nag-edit pa ko rin sa laptop. Kilisan ba sa cellphone, i-share, screen share.
Lisod bitaw, sir. Sige, sir. So, proceed sa mi sa other presenter, sir, ha? Niya,
Sige,
after
mga
ka or after other presenters. Sige,
man ako
can
pa.
we have Sir Manuel Ampak or dili pa ready si sir? If dili pa ready si sir, na naman si sir. Tesa, ha? Sir Manuel, okay. Murag di pa kayo ready si Sir Manuel, no? Kay nakatug daw siya. So, we have Sir Albert D.I.O. Kay ni volunteer si Sir Albert nga pwede daw siya muna. Sir Albert,
Good afternoon, ma'am.
afternoon. Sige, sir, you can start sharing your screen, sir, and start your presentation of the activity that you have.
Makita akong screen, ma'am. Tama, wifi ba?
Yes, sir, makita ra, sir.
Kanang pasensya mo undag gid ko kay kawan nun ari ang gipasignalan ba? Okay ra, mama.
Sige, sir, okay ra kayo, sir, kay
Um,
ready pa po si Sir Ete. Sige na, sir, you can start.
can I kuan ma'am kanang akong i-repeat yung instruction ko wala ba na ko na misheard gid kanina kay guwaong signal. Mopili ra ko sa theorem 1.10, 21 and 1.23, one each.
Yes, sir.
Explain the entire item 2 and item number 3. Sakto, ma'am.
Sige, sir, sakto. And all others
Okay,
kay
so
i-explain na. All other
okay,
parts.
ma'am. So let me begin with item number 1, theorem 1.10. Ma'am, dili lang ko mag-open ka, ma'am, ha, kay cellphone ang gamit mo ba mo ka-block sa screen.
Okay ra, sir.
Okay, ma'am. So we have here theorem 1.10. It is given that A is a subset of A. So we have here if we let A, B, C be an arbitrary sets, and we suppose that A is a set containing M, N, O, P. So for all x that are element in for every x element in A, it is contained in A. So this means that for every element that is in the set A, say M, N, O, and P are all in A. So by fundamental property of reflexivity of subset relation, A is a subset to itself. Number theorem 1.2, we have arin lang ko sa usa. Sa mo ha, sorry. 1.21 og unsa to usa 1.21 ma'am no? Hello?
Sir, theorem 1.21 after theorem 1.10.
What's up, mama? Galibog na ko sa kung kuan.
And hala, theorem 1.23 wala lagi maga-show ang theorem 1.23.
Pwede unahon sa lahon ni 1.23 ma'am, o makita una ba?
Okay, sir, pwede ra, sir.
Okay, so we have here theorem 1.23. Naglet ko A is a subset of B. So given nga we have here A is a subset of B. Asa nakalimot ko sa given ani. Adera day. 1, A is a subset of B. If A is a subset of B, it is equivalent to A intersection of B, which is also equal to A. So we have here, if we let A is equals to a set containing 2, 4, 6, and 8, and we have also B containing 1, 2, 3, 4, 5 until 9, and we set X as a universal set 0 until 10. So A is an A intersection of B is equals to A. It is given based on the um a proposed set A and B. The intersection of A and B is 2, 4, 6, and 8, which is equivalent to A. Hence, A intersection of B is just equals to A itself, given if A is a subset of B. So next is theorem 1.21. So we have here A union A is equals to A, and A intersection of A is equals to A, otherwise known as the idempotent law. Suppose A is equals to a set of a set containing A, B, C, D, and E. So A union to itself is just equals to A, because for every X under A exist in A. So moto nga kung imo sa iyon yun siyang kagalingon, it will just give itself. We also have here A, the intersection of A to itself is equals to, since A is given to be A, B, C, D, and E, the intersection to itself is just the elements inside the entire set E. Set A, sorry, mispronunciation. Now let's go to item number 2, topology and topological space. So the instruction is to provide an example and prove that the example is a topology. So to prove that a topology at a given set or the collection of set is a topology on variable x, it should satisfy the three conditions, which is it should be closed under finite intersection, and each union of the members of tau is in tau. Also, the null and the entire tau should also exist in tau itself. So illustration, I have here a given x to be equal to a set containing 1, 2, 3, and 4. And tau is sets of the null set containing null, containing x, 2, singleton 2, 3, and 4. And we also have a set containing 2, 3, and 4. So first is that we have to illustrate if each union of all the members in tau is still in tau. So we can see here that all the null containing coging union
No.
sa sa every element that is in tau. So and we also have 2, 3, and 4. It would resolve to x as follows: x singleton 2 and singleton 3 and 4. No, not singleton 3 and 4, and we have here 2, 3, and 4, which are all elements in T or under T. So also, if x is combined with all other elements that exist in T, we have here X union with the empty set. We have also singleton 2, we have 3 and 4, and 2, 3, 4. So the answer are as follows: X, 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 and X all are in tau. So we have here 2 union 3, 4. We have 2, 3, 4, which is in T. We also have here 2 union 2, 3, 4. We get 2, 3, 4 still in tau. We have 3 and 4 union with 2, 3, 4. We get 2, 3, 4 still in tau. Hence, the condition 1, which is the union of each um, members of T is in T. Now let's go to the finite intersection. So we have intersection of the null set with x 2, 3, 4, and 2, 3, 4. We all get the null set. So null set is in tau. Also, we have x intersection to each member of tau. We have such as the null, we have 2, we have 3 and 4, we have 2, 3, 4, and we get consecutively we have um, null 2, 3 and 4, 2, 3 and 4, which are all in T. Now let's go to the intersection of 2 and 3, 4, which is in null, and it exists in T. 2 intersection of 2, 3, 4, which is 2, which exists in T. 3 and 4 intersection with 2, 3, 4, we got 3, 4, which is also in T. Hence, 2 is satisfied. While it is obvious that the null empty set is in T and X is also in T, they are they are both true. Therefore, T is a topology in X. Now let's go to the open sets. So open sets by listing, we have here the null set. We have X, the 2, 3, and 4, 2, 3, 4, and for the closed set, just the complement of each member of tau. We have the complement of empty set is x, complement of x is null. We have complement of 2 is 1, 3, 4, and we have the complement of 3, 4 is 1 and 2, complement of 2, 3, 4 is 1. I think mo na correction si mama ni. Now let's go
Sir.
to the
Later na
neighborhood.
ko na, sir, no?
Let's see.
Proceed, sir. Proceed.
Neighborhood of 1, 2, 3, 3 and 4, 2, 3, 4. So 1, the neighborhood of 1 is that all the say tawag na, all the elements or all the set under tau of which one is present. So based on the given tau, we have here asara to. So we have here 0 x 2 3 4 and 2 3 4. I'm not sure though. Sakto ba, ma'am? O galibog ko adi.
Sir,
So
you
we
are
have
asking for the neighborhoods
a
of,
neighborhood ba is under tau ba siya?
yes, sir, all open sets containing the
Sige, sige.
point,
So
the
murag
point
ni
in X.
subra ra ko ani. So 2, so 2 is that its neighborhood is the set x and 2, 2, 3, 4. For 3, we have x, 3, 4, 2, 3, 4. And for 4, we have x, 3, 4, 2, 3, 4. And for 3, 4, we have x, 3, 4, and 2, 3, 4. 2, 3, 4, we have x 2, 3, 4. So thereby, the neighborhood is just the listing of all um, set containing x, which is x is in tau. Now let's go to the larger topology. So let's say T sub O is a topology on X. We have its elements now set X 2, 3, 4, and 2, 3, 4, and we let T sub 1 is equals to set containing now set X 1, 2, 1, 2, 3, 4, 2, 3, 4, and 1, 3, 4. So since T sub O is already verified as given above, so I will just verify kuan ako ra gi-verify so dili na ko itag sa tagisawon. Okay ra? Ako gilista taas kaayo.
Okay ra, sir. Kaya makita man po,
So,
nasakto.
yes ma'am.
Proceed
Akong
na
gi
lang
kuan.
in the explanation why T sub 0 or
Is a
T sub
subset.
1
Okay
is
ma'am.
finer, no? Is finer than T sub 0.
Type T sub 0 is finer ma'am.
T sub 0 is
Larger sa T
finer?
sub.
T sub 1.
Finer kay gamay di ba?
Dili, sir.
O sorry,
Ang
galibog.
finer siya, other term for larger. So, finer siya, murag
Okay, okay.
pareha og fine
Hindi
sugar.
na akong kuan.
Nagkagagmay siya, nagkadaghan iyang element mo
Okay
na
ma'am.
ang finer. Oo.
Balide akong
Oh, nabali.
Thank you, ma'am. Thank you, thank
Sige,
you. I
sir.
stand corrected.
Sige, sir.
Okay, so we have here masarap. It is said that T sub 1, no, as per given verification, T sub 1 satisfies all the condition that must be met for it to become a topology on X. So note that for all X that exist in T sub O, so such as the null, the X, the 2, 3, 4, 2, 3, 4, are also existing in T sub 1. But there exists element in T sub 1, but that is not existing in T sub O. However, T sub O and T sub 1 are both topology on X.
Mm.
Thereby, we can conclude that T sub 1 is a finer topology than T sub O. Okay na, ma'am?
Sakto, sir.
So let's go to 3.11. So theorem 3.11, we have let the set T sub A where such that A is the element of A um be any family of topologies in X. Then the intersection of all the topologies T sub A is equals to the set union of all A which is the element of A, such that also U is the element of T sub A. So is a topology in X. However, the union need not to be a topology. So to prove that the intersection, or to verify that the intersection, to give an example that the intersection of any two topologies in X, which are family, is also a topology, I have given here an example. We have let X is equals to 1, 2, 3, and 4. And we have T sub O. Um, T sub O is equals to a set containing null set X, 1, 1, 2, 1, 2, 3, and T sub 1 is given to be null set X, 2, 3, 4, 2, 3, and 4. So they are both topologies in X. So we have here to see to it if the intersection is still a topology, we have T sub O intersection with T sub 1. Based on the elements given by T under T sub O and T sub 1, their intersection is the null set and the X. So wala na lang ko gipakita ang wala na ko gipakita ang verification since it's obvious nga ang intersection sa null og sa X is the null, and the intersection union of X and null is the X, and X and null set is still in tau. So also on the union of T sub O and T sub 1, we have um, null set X 1, 1, 2, 1, 2, 1, 2, 1, 2, 3, 3, 4, 2, 3, and 4. So these are the combination of the elements, the unique elements under T sub O and T sub 1. So by finding a counter example, we cannot say nga di nato magamit ang ikatulo nga condition, which is null set and X be an element in T kay true naman siya daan. So we can use the union since union man ato ang i-counter example. So I chose 1 and 2, 3. So if we try to union the element of uh, I mean any element, di ba, kay if we are going to verify a topology, um you must sa tawag kuhaon nimo ang union for every element in tau. So here I pick 1 and 3, 4. So 1 union of 3, 1 and 3, 4 is equals to 1, 3, 4. If you are going to see, or sa tawagan na tan-awon nimo sa T sub O union T sub 1, 1, 3, 4 is not existing. So only null X 1, 2, 1, 2, 1, 2, 3, 3, 4, and 2, 3, 4. And 1, 3, 4 is not the element of the union of T sub O and T sub 1. Thus, by the illustration, while the intersection of T sub A is always a topology in X, sayop o pagkasuwat. However, the intersection, the union of, sakto ba yun? Thus, by the illustration, while the intersection of T sub A is always a topology, the union of T sub A is not necessarily a topology.
Okay, thank you, sir. Congratulations. Any clarifications or comments from the report? If none, so I'll give the comments now. So far, for theorem 1.10, justification is complete, no? So it's good, sir, that you have shown why the set A is a subset of A. So sakto to imong gibuhat, sir, nga you have enumerated all the elements of A, which are also elements of A, of course. So sakto to siya kay when we are to claim for kulba ko no, perfect man ang explanation, sir. When you are to claim for a certain expression or equality nga tinuod siya, you have to justify. So in future mga activities na to ha, dili for general audience, ingad tuon na to pag present nga i-justify na to why. For theorem 1.21, kanilang di ay sa theorem 1.21, sir, correct man to no imong gi-explain, but mas better version of presenting it is uh, you can justify a union why a union A is equal to A and A intersection A is equal to A by the definition of union, sir, no, or intersection. So di ba when a certain element is a member of the union, at least element siya sa isa. So ato maning gipakita nga unsay itong issue ani? We are to show that A union A is equal to A. So lagi mahimo siyang element sa union when it's an element of a certain set, but in this example the same ang set nga imong union. So justification lang tingali ang kulang aning theorem 1.21. Solution is all right. And then kadto no, very good presentation for an example of topology kay there is a complete justification of proof from the union of empty to all other members of the set, the union of X to all others, the intersection and all others member pa except empty and X. Complete siya niya katong ingon ka, sir, nga probably wrong. Sakto di ay jud imong answer, dili siya wrong. Tong neighborhoods of all X in X. So sakto ni nga you have enumerated all the X in X, mo na ang mga points sa X, mga elements sa X, and then dili siya one lang ang neighborhood, but it could be more than. Ani, as I checked your answer, correct siya tanan. And so with the finer topology, correct. Theorem 3.11 lang, I wanted you to show, correct ang answer, but for further improvement of the solution, mas okay nga gi-present ang explanation why T sub O is a topology, why T sub 1 is a topology, and then finally why T sub 0 intersection T sub 1 is a topology. If it's obvious kay ang answer nimo ani, sir, no, kay MT and X man, then you can just say nga since the intersection of T sub 0 T sub 1 is equal to the set 0 and X, which is the indiscrete topology, no? So obviously this is a topology. Kanang ingana lang nga solution ako ang needed justification, but minor lang to siya nga comments. And congratulations once again, sir Albert. Okay, so let's proceed to the next presenter. Kuan lang mo follow ko sa mga nakasubmit na og hard copy kay it would be easier for me to verify your answers kung correct ba siya kung na hard copy. So we will proceed to Sir Alan. Ready na si Sir Alan Barrete? Thank you, Sir Albert. Ready na Sir Alan? How about Sir Manuel Ampak? Wala pa. Next to Sir Manuel
Ma'am,
is Sir
um,
Manuel, ready na ka?
yeah, ako lang try, ma'am.
Sige, sir. Sir Albert? Sige, mag-wait me, sir.
Makita ba siya, ma'am?
Visible na, sir.
Unsa ito instruction ni ma'am, mag-pick og every theorem isa na wala mo kabot sa instruction, ma'am, kay na
So,
di na
answer
nakatuog.
for only for Theorem 1.10, Theorem 1.21, and Theorem 1.23, you choose only one from the series of equivalent statements. And yeah, for all other nga activities number 2 and 3, explain na to ang tanan, dili ra ta mag-choose, but kung unsa nang imong submit.
And also for theorem 1.10, okay, I'm going to pick the transitive at A is a subset of B and B is a subset of C. So then A is a subset of C. So so it means that A is in B and B is in C. A is in B, B is in C, and also A is in C. So it means that C has the larger sets which contains B and C. So my example here is A is composed of by the way, mo na akong gamiton nga sets A is consist of 2 or even numbers from 1 to 3, and B is consist of element 2 and 3, which is the prime numbers from 1 to 3. The elements of C is the elements of 1, 2, 3, and I forgot to put the universal sets, ma'am, is the counting numbers from 1 to infinity. Okay, so from theorem 1.10 C. So since A is A is an subset of B, so by definition of subset, so it means that every element of A is also an element of B. So for the second situation, which is B is an subset of C, so it means that B is also is that every element of B must be an element of C. So which means that all the elements of A, or 2, from my example, 2 is an element of 1, 2, 3, as we say that since C consists of A, which is subset of B, and B is a subset also of C. So by definition of subset, so it means that A is also a subset of C. Okay, that's for number 1. For theorem 1.21, I'm going to pick for associative law, or theorem 1.21b, which is the union of A and B is and union of C is equals to A union of the union of B and C. So vice versa, or for the difference. So okay, so for my example, A union of A union of B. So A union of B is, since our A is 2 and our B is 2 and 3, so we need to di ba di na nato i-copy ang same of element, so we will write 2 and 3. Okay, 2 and 3. So union of C, our C consists of the element 1, 2, 3. So we must show that these two these two must equal. So that's why I need to or I need to show nga mo equal jud silang duha. So even though di sila pareha og uh, pagka-solve. So since the right part is A union of B union of C, so our A is 2 union of B, which is 2 and 3, and then union of C, which is 1 2 3. So the union of B and C is the union of that 2 is 1 2 3. We need to copy the common element of the 2 of the 2 of, of the B and C. So next is in the left side, the union of 2 3 and 1 2 3 is 1 2 3 is equals to, okay, same na sila sa union sa picasad, which is 1 2 and 3. So it means that the A union of B union of C is just equal to A union of B multiplied by the union of B and C. Okay, next is so, so the difference of the difference of A and B times the difference of C is just equal to A intersection. I mean A intersection of B intersection of C is just equal to A intersection of the product of B intersection of C. So from the example, so same gyapon sa pag-solve, and then we only need to get the intersection. So this the 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 element that is common for the both set. So the common of 2 and 2 3 is 2. Oh wait. So, yan. Dara de. So the common of the two set is 2 2 3. 2 and 2 3 is 2, and sa bigas is the difference of B and C is, which is ang B is na contain siya 2 3 element, and sa C is 1 2 3. So the common is 2 3. So ato na siyang intersect sa left side, o atong intersect siya sa C. So 2 intersection of 1 2 3 is 2. So 2 raman ilang same element, so the set will be 2, and the sa right side is equal to 2 intersection of 2 3. So ang ilang difference is 2. So it means that the intersection of the two statement is the two statement is equal. So it means that the product of the intersection of A and B intersection of C is just equal to A intersection of the product of B intersection of C. Okay, next, theorem 1.23. Theorem 1.23 is akong gipili is karing kuan mo C. Karing C siya ma'am, walang guna ko na nabutang sa akong previous nga kuan ma'am, sa previous nga na wala ang C. So ako na lang pilihan
Sige.
kung wala sa C. Atong wala.
Sige, sir. Wala sa imuhang naaman dire sa imong hard copy.
Okay, nang gusto
Nasya sa
copy
imong
man
hard copy.
nakalimot og cap. Napicturean ako daan mo ba kay mag-send magod. Nag-send mo gusto kuan ka ng I mean kanang mag-send ba niya mo tanap mo kung makani dapat nga part mo magdalabay correction.
Mm. Sige,
Okay,
sir.
nakoy answer ani. Nang karon ako nagama ni ma'am, pero nang parihar ako nag-answer sa akong answer diha ma'am.
Okay,
Okay, so
yes, sir.
okay, so we will use the same set nga akong igamit sa babaw. So set A contains of 2, and our U is the natural numbers, natural counting numbers, so from 1 to infinity. So ang akong gigamit ani is B complement is a subset of A complement, given that if A is a subset of B. So kani siya is we need to prove is subset pa siya. So from this problem, di ba, maglibog man ta nganong nadako na sad si B complement kaysa ni C, since nga A is a subset of B. So it means na the B is or is a large element than than A, since nga i-subset naman si A ni B. So first is we let for example, we need to kani akong i-giving nga example is kuan mo siya kanang counter example. So pwede ra ko mag after na lang na siya. So for example, we need to pick one element nga gikan sa B complement. So according to the definition of B complement is complement nga ang complement sa isa ka set is consist of element nga wala ana nga set. Okay, for example is kanang sa B complement. So ang atong B complement nag-consist na siya og element nga nag-consist na siya sa tanang element nga wala ni B. So it means that this means that element or x is an element of B complement if and only if kana si x is dili siya element ni B. Okay, so by definition of complement. Okay, so sa ato ang given nga condition nga A is a subset of B. So this means that every element of A is also an element of B. So basic na nato na no kay by the definition of subset. So dili na ta maglibo kana kay subset na siya. Okay, next. Okay, since A is a subset of B, so A is a subset of B. So if A is not a subset of B, then X is not a subset of A, di ba? So from diri sa ta sa A subset of B. So kung ang katong atong X nga dili siya subset sa B, so it means dili pa siya subset sa A since nga si A subset siya ni B. Okay, so subset relationship na siya, so na mag-consider tag element nga X. So mo to siya kung wala siya sa B, wala siya sa A. Kaya dili mo sa pwede nga nasa siya sa B, then na possibility nga nasa sa B nga wala siya sa A since B is greater than, pero atong i-pick nga nasa sa A nasa sa B, nasa sa A. So mag-contradict siya kung wala siya sa B nga nasa sa A, kay B is one larger set than A since B contains A ay si A na ni B. So therefore kung magkomplementa at ina-complement na to, so it means na si X is a element of B. So mo implies na siya nga X is an element of A complement sad. So kung si X nga atong element nga atong gipick nga atong gipili is an element of a B complement, so mo implies ba ta nga X is also an element of A complement, kay mag-contradict man siya kung dili siya mo element. So yan na siya. So nang by the way, ma-change na ang by kanang sa pag-graph mo ni kay magunaw na tagtulo ka atong ubot nga upat ka circle, and then A is the smallest, and then gi-contain siya ni B, unya gi-contain siya si B gi-contain ni A, and then gi-contain ni C, and then si C gi-contain sa universal. So it means na nga mas dako jud si B di ba kaysa ni A. So when we say magkomplementa, ma-change na siya. So it means na ina-complement nato, instead nga ang si A is smaller siya ni B, ina-complement mahimo siyang ang tanang element sa sa B complement mogamay siya kaysa ni A complement. So it means na nga mas dako na si A complement. So from the example na nga gihatag is ang atong n is counting numbers, not dili siya 2 3. So when we say B complement all the counting numbers not 2 3, kay si 2 3 is the B man, so dapat dili siya si B, kay B complement man is a subset of all natural numbers not 2, kay ang atong A is 2 man, so ina-complement na to is dapat dili siya apil sa element. So from the kanang illustrative example, so dili man siya 2 3, so it means nga ang atong element sa pikas is 1 4 and 5, so wala abot si 3, and then is a subset of 1 3 4, kay not 2 man, so atong latangan si 2, so 1 3 4 etc. to infinity ana. So 1 4 5 sa pikas and then to infinity. So it means that B complement is a subset of A complement, kay di ba mas dako na siya, mas labaw lang o gamay si A complement since naa siya 3, pero subset na siya. So it means na nga subset si B ni A complement. subset si B complement ni A complement. Okay, next. Okay, next is topology and topological space. So I let the set X which consists of element LMNOP. So magama tag topology ana. So akong nagama nga topology is T sub O is equals to an element, nakalimut ko close na. Null set X O N O P. So nakalimut ko close mo. So T sub 1 is equals to the null set X O O P N O P L M N P. So mo na siya mga topology nako. So okay, so topology na siya kung gikan na siya sa X or a subset of X. Pero ang topology is na siya is a part of gitawag na tawag power set. So ang dapat ang topology is na belong siya sa ato ang power set. So mo na siya. Then ang topological space is katong pares na si X and a topology. So mo na kung naibuan nga the TOS or the topology of the TO is mo ang katong first nako nga topology which is nasa babaw, and then topological space, so S is TS yun sa mga. So it's just equal to parisan na nako ng every element niya sa X. So the first pair is X and null set, and the second is XX X and then element of O X and NOP, as well as the T sub 1 or the topological space of the T1 which is X null XX XO XOP XNOP XLMNP. So ito mo na yung mga topological space nga na-create nako sa duha ka topology nga akong gihatag sa babaw. Okay, next is the open set. So ang open set is set na siya sa topology sad. So ang akong gikuha nga topology is matawag siya nga open set kung naa siya sa duha ka topology. Naabo niyo. So open set na sa X XOP, so nabatay okay sa intersection O OP NOP and LMNP. So matawag ni siya ka open set kung naa ang mga union intersection sa every set niya. So union of OP na OP, the intersection of O and OP is O, intersection of NOP na asad. So intersection of LMNP, so not intersection which is null set. So sa open set so next is union sa NOP. So NOP sad naa. The union of LMNP, so naasad kay naman si X. So X is consist of all the element OP. So naata tanan no, so matawag na siya nga open set kung nasa tanan and then topology sad. So ang closed set is just only the complement of the open set. So ang complement sa O is LMNP. I mean the complement of the null set is X. The complement of X is the empty set, the null set, and then the complement of the O is LMNP. The complement of OP is LMN. The complement of NOP is LM, and the complement of LMNP is O. So mo na siya, ma-complement na siya sa open set. Matawag na siya nga closed set. Okay, next is neighborhood. Neighborhood is an element where X is an element of X and contained in tau. So the neighborhood of X, so ang akong gigamit ano is T1 ra. So ang neighborhood niya is
Ko answer ang neighborhood kay katong mga elements sa T1. So mamili ka ana.
ang akong X is tanan. So akong gibutangan ni is T1 ang neighborhood sa sa null set is naa man siya tanan na, di ba naa man siya tanan ang null set, so naa siya tanan, so T1 sa akong gibutang, wala na ako gilist tanan. So the neighborhood of L is kanang naa siya sa set nga naa si L. So since nga si L is nasa X, since contain mo siya element OP, so naa sad siya sa X as well as the LMNP, so dili ta pwede mag neighborhood of OP since wala siya L. So neighborhood of M is X and LMNP since naa si M. Neighborhood of N, so the neighborhood of N is X and and NOP, set of NOP and set of LMNP since nga naa si N. As well as si O, naa po sa si O sa X, sa O, and then sa OP and sa NOP. The neighborhood of P is X, so naa sa naa P sa X, OP, NOP, and LMNP. Okay, and the next is the larger topology. So ang larger topology is nag-contain na siya og topology nga na-contain of larger subset. So nagkatong akong example nga duha ka topology which is TO and T1. T sub O and T sub 1 is katong nasa baba mo ra gyapon niya akong gigamit. So ang larger topology is nag-contain siya og larger subset. So it means na nga asa mas daghang subset, di ba ang T sub 1. So note that the T sub O is a subset of T sub 1, then we can say that T sub 1 is a larger or finer topology than T sub O kay mas daghan man siya og subset. Mas daghan man siya og element, an element of element to because it contains more element than the topology of from the topology of X. So mas daghan siya topology. I mean mas daghan siya element nga gikan sa X kaysa sa atong T sub O which is only pila man ka element 4. Sa atong T sub 1 is 1, 2, 3. So 6. Oh, 6. So, di ba 6 is greater than 4. So mas daghan siya. So ang larger or finer topology is ang T sub 1. Okay, last is illustrate theorem 3.11. Let the set of topology be any families of topology in X, then the intersection of the topologies which U is U such that the for all alpha element of A is a topology in X. So the union of the topologies need not to be a topology. So okay, sa akong gigamit nga set is ang set kani nga gagman akong example good. So ang akong gigamit is only the set M and N sa X. So ang iyang topology nga ang akong gigama nga topology is 2. Ang kakuha rin siyang ginama ani is only 2. The TO and T1 which consist ang TO is na-consist siya of null set and X and M. Ang T sub 1 is null set X and N. So the intersection of T sub 0 and T sub 1 is a null set and X, di ba? So kani siya is an open set. Open set na siya. And then na-contain na siya sa both, di ba? Naaman si null set of si X sa T sub 0 and T sub 1. So that can be found in both topologies, especially in TS. So di ba sa topological space is naamo na siya. So however TO and T1 not necessarily a topology because the union of set T M and N, di ba ang kung atong union si M o si N, di ba dili na to siya makita sa both nga topology. Di ba wala yung MN nga topology, so bisan pa og so kung as we look back sa atong T sub 1 wala tayong makita nga MN. So it means na nga bisan pa og naa sila intersection nga both nila makitaan, dili po necessary nga natay makitaan nga nag-union na to is a topology pud siya. So it means na it means that because the union of set M and N or M union of N which is equal to Mn, di ba? That is not found in T sub O or nor in T sub 1. Thus, it fails to satisfy the problem. So, muna siya exemption. So, the union of T sub O, T sub 1, T sub T sub O, and T sub 1 is na-consist na siya og null set X, M, and N. So, thus, this is necessarily a topology since the set Mn is not found in the union of the T sub O and T sub 1. That's all, ma'am.
Okay, thank you, Sir Manuel. Any comments or questions or clarifications? Sige, nako na yung question si Sir Albert sa neighborhood. Neighborhood, sir. Sir Albert?
Ma'am, kanang mutana ra ko ma'am ba?
Yes, sir.
Di ba ang
Mm-mm.
neighborhood kay neighborhood kay sets man siya under tao.
Yes.
For example, we pick an arbitrary set under tau. Unya, for example, let's say X. So, ang neighborhood di ba ma'am kay kuan man ang any all the sets in tau that contains X.
Yes, sir.
Ang pangutana adto kay kadto bitong NBD of null of NBD sa
Mm,
NBD sa kuan
of
sa
X. Sa X.
sa X.
Yes,
Murag
sir.
dili sa T1.
Oh, sakto, sir. Sakto to, nga comment. Part po to sa akong i-comment later. Thank you, Sir Albert, for kanang being interactive with the presentation. No? So, general comment, ako tong i-answer po ang question ni Sir Albert later. No? Mag-start ta sa Theorem 1.10. Kuan man no, we are to illustrate the theorem. So, kung mag-illustrate tag theorem, pasabot is mag-show kag example and justify nganong tinuod siya. So, kanilang sa katong gi-explain ni Sir Manuel katong sa C, showing A is a subset of B and B is a subset of C, then A is a subset of C. So, ang best presentation ay nag-show man ka ani Sir no og A equals 2, B equals 2 and 3 and C equals 1, 2, 3. So, okay na ni siya nga pag-graph sa set. Ang further enhancement na lang ani Sir sa explanation is kadto lang kanang imo lang i-explain. Explain nimo nga nganong si A subset ni B because all elements of A kay only 2 ra man yung elements, so elements of A kay 2 is also an element of B. So A is a subset of B. Unya si B is a subset of C. Tanan po nga elements ni B subset po ni C no kay 2 and 3. Unya C kay 1, 2, 3. So by transitivity, since A is a subset of B and B is a subset of C, we can say that A is a subset of C. Kana lang siya ang i-add sa explanation later para ma-clear gyud nganong subset siya. But kaning mga sets nga given diri kay clearly kung mayon ra tag clearly subset man jud siya no. Kuan lang ato lang siyang i-explain. And then, kuan po, how can we improve the presentation for Theorem 1.21? Bisag asa aning component sa Theorem 1.21 pero ang explain ni Sir kay associative law man to no. So, pwede nga ang first way of showing na to is show na to unsay value sa A union B union C. Later pa ta mag-equal. So, gaman na to ang computation sa A union B union C hantod sa simplified answer and then second set sa solution kay kadtong solution na po sa A union close open parenthesis B union C, and then the last statement will be to make a conclusion nga nganong equal sila. Of course dapat mapakita sa first set of solution nga pareha siya answer sa second set of solution. Pero naa naman diri ang kuan lang ang arrangement of the justification. And kadto pod no, showing B complement is a subset of A complement. Pwede ra jud nga i-sentence ra ninyo. So since for example katong gi-explain ni sir nga B complement is a subset of A complement, pwede ra ta moingon nga since all by illustration above, since all elements of B complement are also elements of A complement, and A complement has more elements than B complement, so we can conclude that B complement is a subset of A complement. But walay problem man sa kuangan lag gamayng justification. And then kadtong sa topological space no, definition 1.15, when we say space, the word space shall mean an empty set which possesses some type of mathematical structure. So kung moingon tag topological space, kuan lang siya kanang dili na nato i-pair tanan sir sa tanang elements, but only the pair X and the set tau. Mao na siya ang gitawag nato og topological space. So when we represent X tau as a topological space, ang iyang bearing is kani si tau ani with respect to the set X satisfies the axiom of a topology katong tulo ka buok. Mura na siya bearing. But dili na nato i-pair tagsa-tagsa. And kadto no, kanang detailed solution based on the three axioms y, kaning t sub 0 and t sub 1 diri sir is a topology. And katong question ni Sir Albert on the neighborhood no of x in x, for the neighborhood of x, the set x, dili ti sub 1 atong answer no, kay usa ra man from among the open sets presented, usa ra ana ang mo contain, usa ra sa open sets ang mo contain ni x. So the only neighborhood of the set x is x alone, kay siya man ang pinakadako. And then the neighborhoods of empty, kay kadto i-enumerate ang empty, comma, sakto di ay, sakto ang comment ni Sir Albert nga dili ti sabuan atong isuwat, kay kung moingon tag neighborhood dili siya set man. Ang ti sabuan is a set, but kung moingon tag neighborhood, it's the elements of the topology. So mag-enumerate ka aning tanan. Though I understand unsay gimin ni Sir Manuel, mao niyang gimin, pero ang right way of presenting is sulat na to tanan. Empty x, the set 0, the set O, the set OP, the set NOP in comma O, comma P, and L, comma M, comma N, comma P. And then kuan di ay, please don't forget to write comma after every other elements no. Kay kung LMNP kay marag 1 element ra siya. When we write a set, the one way to identify nga it's another element is it is separated by comma. So tangan na to comma. And then kadto pod for theorem 3.11, instead of using the word found, we can make use of open, since empty and x are open in tau or are elements of tau. Kana then we can conclude nga t sub 0 intersection t sub 1 is a topology. Kadto lang. Nanoted raman to Sir Manuel no?
Yes, ma'am.
Okay, sige. Further clarifications on the neighborhood, nagkasinabot ra ta adto sa neighborhood. So for T sub 1, neighborhoods of x, si x lang. Ako ra pong i-correctionan man dire sa write-ups. And then for neighborhoods of MT, 1, 2, 3, 4, 5, 6. Ag 6 ka open sets ang iyang neighborhoods. Okay, thank you and congratulations Sir Manuel Ampak. Okay na to akong answer adto Sir Albert on the neighborhood satisfied ra ka no sa explanation nagkasinabot ra ta Sir Albert. Sige, marag signal ni Sir. So we will proceed to Sir Alan. Ready na ta? Sir Alan Barretti. If not yet ready si Sir Alan, so can we have Sir Cortidor? Sir Cortidor. Mark Kevin.
Good afternoon, ma'am.
Afternoon, sir.
It's how's the position? Oh, nakita na ba, ma'am?
Makita na, sir. Sige, you can start.
Okay, good afternoon, everyone. So, I'm going to start with theorem 1.10. So, let A, B, and C be any sets, then A is a subset of A. So, I'm gipili. So, I have here an example to prove this one. So, we have the set A, which consists of 12 and 24. So, A as a subset of A is, so we have here 12, 24, subset of 12, 24. Thus, every element of A is also the elements of the subset of itself. So, just the same subset kung i-subset pa nato siya sa iyang pagalingon na set. Okay, now let's proceed with term 1.21. I choose idempotent law. So we have A union of A equals A. And A as an intersection of A is also equals to A. So to prove this one, I have here an example, which is A, the subset A consists of 12 and 24. So I have here A as a union of A is equals to, I have here 12, 24, union of 12, 24. So it will arrive with 12, 24 since the union na nilang duha kay pararaman sila common 12, 24, which is equals to 8. Now let's have the intersection of A and A, which is equals to A. So to prove this one, let's have an example. I have here subset A consists of 12, 24, and A intersection of A is equals to 12, 24 intersection of the subset 12, 24, which is equals to 12, 24, which is equals to 8. So, na-prove na siya na equals to A agad ang union or intersection sa A and A. Now I have here theorem 1.23. I choose A as an intersection, union of B, which is equals to B. So to prove this one, I have here an example. I have here A is equals to 12, 24, and B is equals to 6, 12, 24 set. So A union of B is equals to the set 12, 24, union of the set 6, 12, 24. So, kung union yung duha, so ang common nila would be 6, 12, 24, which is equals to the subset or the set B. So I choose number 2, I choose the open sets, closed sets, and neighborhood of X. So I have here the X, or which is consists of 6, 12, 18, 24, 30, and the tau, which is equals to empty set, the subset, the set X, and 6, 8, 24, 6, 18, 24, 12, 18, 24, 30. So the base here, the open sets are the empty set, X, 6, 18, 24, 6, 18, 24, and 12, 18, 24, 30. And for the closed sets, so we have here the empty set, X, 12, 18, 24, 30, the set 6, 12, 30, the set 12, 30, and 6. For the neighborhood of 6, we have here the set x, 6, and 6, 18, 24. So I have here the theorem 3.11. So let x is equals to the set here 6, 12, 18, 24, and 30. And let's consider the two topologies here, which is the tau 1, which is equals to the empty set x, the set 12, 18, 12, and 18, 12, 18. And the tau 2, which sub 2, which is equals to empty set x, 18, 24, 12, 18, 18, 24, 12, 18, 24, and the set 18, 24, 30. So if we are going to intersect the 1001 and 1002, we have here the empty set x, 18, 12, 18. And if we are going to, we have here the union of tau sum 1 and tau sum 2. We have here the set, the empty set. We have the x, 12, 18, 24, 12, 18, 18, 24, 12, 18, 24, the set 12, 18, 24, 30. And if we are going to, I mean, if the 12 union of 24 is equals to 12, 24, which is not an element of tau 1 union tau sub 2. Alright, ano to siya, ma'am?
Thank you, sir. So very short. Paspas lang kayo na ang presentation ni sir.
Sorry, ma'am.
Okay naman. Correct. Correct. Correct man siya. Sige. Kuan lang, some minor errors. Some minor errors. Dili na siya error. Dili siya error but kuan kanang katong mag-show ka sa A subset sa B, B subset sa A. Unya dapat equal silang duha. So ang example nga gihatag ni Sir diri kay A equals 12 and 24 nya B is equal to 12 and 24. Meaning pareha ang set. Okay good siya. Walay problema no kay kadang equal man siya pero trivial siya. Trivial ba nga obvious na kaayo nga equal si A ug si B kay pareha man sila sulod. Better example would be gamay nga set si A nga subset sa B, mas daghang element si B kaysa ni A. Pero okay guni, walay sayop man ani. Another is sa topology katong when you get the union of union x or no, ani ang answer kay the set x. So tanggalon na to ang brace nga the set x. To all others kay ang x ani is the universal set composed of 6, 12, 18, 24, 30. So tanggalon lang ni na to kana lang minor ra siya. And then kuan katong sa neighborhood nga example for neighborhood of 6. So neighborhood of 6 kay okay, imply arrow din eh. No problem with the solution for neighborhood of 6. Kulang lang og katong solution sa neighborhoods of all other elements. So, dili raman 6 ang elements sa gishow ni sir. Napay 12, 18, 24, and 30. And for the proof sa theorem 3.11, kadto, same comment sa previous nga when we claim T sub 1 and T sub 2 topology, atong i-show no, T sub 1 is a topology, nganong T sub 2 is a topology. Kung dili i-exhaust, i-explain lang. And then, finally explain why T sub 1 intersection T sub 2 is a topology. As well as the union, okay naman dire, naa siya gipakita nga element nga 12 and 24 nga dili element sa tau sub 2. So after ani, what after? Kung dili siya element sa tau sub 1 union tau sub 2, further explanation would be there is an open set tau sub 1. There is an open set 1224 which is not an element of not an open set. Therefore, kana. Ingana ra. Thank you, sir, and congratulations. So far, correct na to yung mga solutions. Next, ani na tani, ma'am, ready na si Kuan. Ani sa tani, ma'am Rochelle. Rochelle, daog-daog. Wala pa si ma'am Rochelle. Can we have, oh, Kuan, can we have ma'am
Wait
De La
sa ma'am.
Victoria? Ready na ka, ma'am?
Kato na lang siguro akong picturean ma'am kay gawang laptop magud kay nalubat niya. Ang charger kay naa sa office nabilin.
Okay,
Sige
so,
ma'am. Wait sa ma'am. Makita ng screen ma'am.
yes, ma'am. Pero, ako ang naong ako nakita.
Nana sige ma'am.
Sige.
Nag-cellphone ro magud ko ma'am kay nalubat akong kuan.
Sige. Ano, ma'am?
Okay, so let's start my report. Let's start with the theorem 1.10. So let A, B, and C being set, then I choose this number 2. Naman to. Nawa na ko. So A is a subset of B and B is a subset of A. Then A is equal to B. So I present here the example nga kanang set we have 10. A is equal to the set containing 10 and 20 and B is equal to the set containing 10 and 20. So mura siya og wow sakto ba ni ma'am? So A is a subset of B. It means that every element in A is naa siya sa B. So as you can see, then B is the subset of A, which is every element of B is a subset of A. So therefore, A is equal to B, which is 10 and 20. Thus, every element in A is also an element in B, then every element in B is also an element in A. So hence, A is equal to B. Next, theorem 1.21. So let's have the commutative laws. A union B is equal to B union A. And A intersection B is equal to B intersection A. So we have here the set. A is equal to the set containing 10 and 20. And B is the set containing 5, 10, and 20. So as you can observe, A is a subset of B. Then let's cite an example of A union B. So A union B, it has the set containing 10 and 20, union the set containing 5, 10, and 20. So ang union nila is we have 5, 10, and 20, which is also equal to B. Then let's have B union A. So the set containing 5, 10, and 20, union to the set containing 10 and 20. So the result is also B, which is 5, 10, and 20. So equal C A union B and B union A. So let's have the intersection of A and B. So A intersection B, so we will going to use the same set. A is equal to the set containing 10 and 20 intersection to the set containing 5, 10, and 20. So ang intersection nila, na siya 10 and 20, so which is equal to A. Then next is B intersection A. So ang B na to, we have the set containing 5, 10, and 20 intersect to the set containing 10 and 20. So ang mga element nga equal sila or naa siya present sa B na apod siya sa A, we have the set containing 10 and 20. So equal sa A gyapon. So therefore, ang A intersection B is equal to B intersection A. So as you can see in the presentation of the diagram, the A union B, so all the elements present in A and B. And for the intersection, so katurang common nilang duha. So na siya naka-shaded parts. Next, we have saan man ni? Theorem 1.23. Okay, so let's have the number 2. A union B is equal to B. So as what I have said ganina, nga A union B, pag ang result is B, then it means that A is a subset of B. So we have given here an example, the set containing 10 and 20, union to the set containing 5, 10, and 20. So ang result niya is B. So this means that A union B is equal to B if A is a subset of B. Now let's have the topology. So as stated here that it should provide a detailed solution. So if X is a topology, if it is satisfies the three axiom, first is the intersection, a union, next is the intersection of the topology and the tau, then ang ilahang empty set and X is also an element of tau. First, let's have the union of tau. Kani siya. Makita ba siya, ma'am?
Yes, ma'am. Kita ra.
So natay tao nga contain na siya set nga empty X, the set containing 10, the set containing 30 and 40, the set containing 10, 30, 40, the set containing 20, 30, 40, and 50. So muna na giset na to nga tao. Now let's find the union kung naabagyapon siya sa tao. So dera atong mga solusyon murag taas-taas yun siya. No? The union of empty, union empty is equal to empty. The empty union X is equal to X. Then, pag ang empty union siya sa elements nga naa sa tau, then, ang answer ana is katong element. So, we have empty union sa the set containing 10, isang result is the set containing 10. Next, yan na siya. Then, we have kanipod. So, sa ako pong pag-solve ani is tanan nga result sa union is nagyapon siya sa tau union tau. So this means that kani atong T is kuan siya kanang topology ang iyahang union. Then let's have the intersection. So we have here the intersection empty, then X. So ang intersection sa both nga tau. We have the set containing 10, the set containing 30, 40, 10, 30, 40, and the set containing 20, 30, 40, and 50. So to get the intersection, so every intersection of an empty set is always an empty set. So kana siya tanang empty, intersect nimo og kuan, empty siya. Then muni siya ang kuan. So far naa siya tanan sa atong intersection. Si empty, napod si X dere, kani dayon si 10, napod si 30 and 40 nga set. The set containing 30, 10, 30, and 40, and 20, 30, 40, and 50. Muna siya. Then, ang last nga axiom is dapat si empty and X is element sa ato ang tau. So, as you can see, ang tau na to nga nakaset diri sa babaw is naa siya empty and X. So, therefore, ang atong tau is a topology. So na-satisfy niya ang 3 ka-action. Next, let's have the open set, close set, and neighborhood of X. So let's start with the open set. So the same kanang kuan value of X. We have 10, 20, 30, 40, and 50. Then the open set here is from the given topology, from the given tau. So tau is equal to the set containing empty. Klaro ra ba? X, nung naputol lagi ni. Naputol siya. X, empty, X, the set containing 10, the set containing 30, 40, the set containing 10, 30, 40, and the set containing 20, 30, 40, and 50. So the open set ano niya is we have the empty, the X, 10, the 30 and 40, the set containing 10, 30, and 40, and the set containing 20, 30, 40, and 50. So to get the closed set, we need to subtract X by the open set. So, ang X na to is natay the set containing 10, 20, 30, 40, and 50 subtracted by kaning open set nga kani. Kung empty, subtract mo to siya empty ang result kay X. Kung kaning X minus X is we have empty. Then X minus 10 is we have the set containing 20, 30, 40, and 50. Then X minus 10, X minus 30, 40 is we have 10. The set containing 10, 20, and 50. Then X minus 10, 30, and 40 is we have 20 and 50. And the set contain X minus the set containing 20, 30, 40, and 50 is the set containing 10. So, na siya. So, ang neighborhood na ko kuan kay ang example na ko diri is only one. So, mangita tag na ay dai kuan, murag daghan-daghan ni siya. So, neighborhood of 10, naman siya dito. We have X. Kay si X kay nag-contain man siya set nga 10, 20, 30, 40, and 50. Then neighborhood po siya sa iyang kaugalingon. Then the set containing 10, 30, and 40 based sa atong tau sa naa sa gi-present sa babaw. Then the neighborhood of 20 base sa tau is we have the X, of course. 20, the set containing 20, 30, 40, and 50. And for 30, naagya siya sa X, then naapod siya sa the set containing 30 and 40, and the set containing 20, 30, 40, and 50. And for 40, naa siya sa X gihapon, then naapod siya sa set nga 30 and 40, and naapod siya sa set nga 10, 30, and 40, and 20, 30, 40, 50 nga set. Then for 50, naa siya sa X, of course. Dayon, the set containing 20, 30, 40, and 50. So, wala na ako gi-include si X dire kay X ra man pud siya. So, ang neighborhood sa X is iyang kaugalingon ra pod. Then, let's have the theorem 3.3. So, ang akong na-submit dira ma'am is murag topology jud siya tanan. So, wala jud exemption sa iyang union o intersection. So, nako gi-provide para mas mauban ni. Ay, sa, wala de, tara de, ari. Nangamali na dyan ni. Dara siya. So, mo ni siya ang akong nag-gikuan. Nag-site ko kuan. The same gyapon nga set. So, let X be the set containing 10, 20, 30, 40, and 50. And consider the two topologies. So, we have the T1, the set containing empty, X, the set containing 10, 20, and the set containing 20, and the set containing 10 and 20. And we have also the T sub 2. So, di ba, ang theorem 3.3 nga kuan siya, dapat ang iyang intersection is topology. Topology gyapon siya, bala ang iyang union is not a topology. So makita man nato ang intersection ni T1. So dapat before nato siya ikuha ang intersection, dapat ang iyang T1 or the tau sub 1 is dapat siya topology alone. So the empty set, of course, ang union ni kanini nila is we have 10, naa ba si 10 sa tanan? So naa siya union sa X. Na siya niya. 10, the set 10, union niya. 10 union 20 is napod siya dire. Si 10, the set containing 10 and 20. So intersection nila empty, wala man sila makuan. Then there is a T sub 2, we have ang union sa 10 and 30 naa siya dere. The set containing 10 and 30. Then the union of 10 and 10, 20 is we have 10 and 20. Then the union of mali na jud ay jud siya. Mali jud siya, ma'am. Napa din ni siya 10, 20 and 30.
Hmm.
Natibok na jud ko. Murag tulo na jud ka solusyon eh. So murag mali jud akong theorem 3.11. Isa asara to. So mo na siya, then mo na siya. The intersection is we have empty. Gisundog ra mo gud ako siya sa kuan, ma'am, katong example kay galibog naman jud kog tama.
Ah, ayaw ra to sunduga makalibog gyud to. Dapat
Lagi so so
guided
atong kuan.
guided ra ta sa tulo ka actions.
So ang intersection nila is we have empty, X, the set containing 10, and the set containing 10 and 20. So ang union nila, so we have empty, X, 10, the set 10, the set containing 20, the set containing 30, the set containing 10 and 20, and the set containing 10 and 30. So it's not a topology since ang set nga 20 and the set containing 30 is element siya sa T1 union T2, but ang kani kung union na to ni sila, we have the set containing 20 and 30, which is wala siya sa atong T sub 1 union T sub 2. So I think that's it, no.
Okay, thank you, Ma'am Rochelle. A virtual applause for Ma'am Rochelle. Kalimot di kog ingon sa mga previous presenter, no. Dapat mahatag gyud tag virtual applause kay it's not easy to present, and as well lahi po that ang impact when we had the presentation. More we can understand more when we do presentation. So ato lang daghanon kay ang uban kay wa man din nato na pakpake niya. Sige. So general comments so far for the sequence of solution nga gi-present nimo, ma'am, kay maayo ang sequence of presentation, like for example katong showing commutative laws, A union B is equals to B union A. So maayo to, ma'am, no. It's good that you presented first unsay answer sa A union B, and then another second set of solution kay you show the answer for B union A, and then ang kulang na lang ato, ma'am, kay i-conclude jud nimo since A union B is equal to 5, 10 and 20, the set 5, 10 and 20, and B union A is equal to the set 5, 10 and 20, then the conclusion holds, or then we can say that A union B is equal to B intersection A. So murag ingani na jud ang mga tips when you do the writing, the formal writing in ko ano pure mathematics, katong i-sequence ninyo ang inyong mga arguments leading to the conclusion. So okay ni siya, Ma'am Rochelle. Kuan pod at minor correction lang sa theorem 1.10, instead of using the word thus kay mara nam kag ni conclude. So dapat since ang gamiton ani, since every element in A by computation above, since every element in A is also an element, are also elements of B, then we can say that A is a subset of B and B is a subset of A. Therefore, A is equal to B. Gamay ra ang das, no, pero lahi na ang meaning sa since. Kana. And then same comment, very good that you have the complete solution, no, for complete solution showing that the collection here sa imong example is a topology. Same atong ka sir ko Albert. And then kadto lang, when you get the union of X and X, the set X siya but wala ning brace, ma'am. X union 10. Wala ning X kay kung wala ning brace kay kung brace nimo mahog siya o element dili siya set. So this is just equivalent to the set X, in which the set X is consist of the set 10, 20, 30, 40, and 50. And I think that's it. Thank you and congratulations. Sa neighborhood ay katong gi-present nimo sa neighborhood, ma'am, no, kay usara diri. But sakto tayo mong gishow sa presentation. So thank you, Ma'am Rochelle. Next, can we proceed to Ma'am De La Victoria, or ready na ba si Sir Alan Barrete? Ready na ka, Sir Alan? Excited na ra ba si Sir Rafael? Ready na ka, sir? Dili pa?
Madungog ko, ma'am.
Oh, yes, sir.
Kananay, akong
Doon ka, sir.
gamiton cellphone ma'am sa ko ang mic kunya sa laptop ko mag-screen share. Lisod nagbuang-buang budong kuan, ma'am.
For all, sir.
Kanang
Kuan, i-mute lang imong laptop, sir. O niya, i-on lang ang imong cellphone. Para dili
sige.
mag-echo. Sige, sir.
Okay, kanay ma'am.
Wala na echo, sir. Okay na.
I-off sa ako ang camera. Actually, sige. Pero mauwa nung kuha ni ma'am, kilagmi man kayo sila ma-present. So, madungog ra ko. Madungog ra ko, ma'am.
Yes, sir. Sige, sir. Go
Okay.
on, sir.
So, presenting. Asa mo kuha niya? Screenshot. Asan ba akong presenta niya? Ma'am, kadiyot sa mama, kaya murag wala doon magkadimaori akong kuhaan, ma'am.
Excuse Ma'am Rochelle. Mao siguro di siya ka share kay murag wa pa nimo na off imuha.
Dara. Okay. Ano ba ni? Loading ko lang sa man eh. Dili gyud ko kasulod.
Would you like, sir, nga I'll be the one to present your slides? Ano ikaw ang mo-discuss?
Kaya, sige, pwede ra po, ma'am. Sige, ma'am.
Sir, send lang sa messenger, sir.
Okay. Paway sa lang ko, ma'am. Ako sa lang tarungon niya ako, ma'am. Okay ra? Nansa naman.
Sir, sige, sir. Ari sa proceed sa tani, Ma'am De La Victoria.
Salamat, ma'am. Salamat.
Okay, sir. Ready na ka, ma'am? Ma'am Desi Rose. Desi Rose, no? Can we have Ma'am Mercy, Ma'am Hamora, Ann Mercy Hamora?
Good afternoon, ma'am.
Good afternoon.
So, nara ba yung nakita, ma'am?
Wala pa, ma'am. Wala pa ka naka-share. Okay na, ma'am.
Okay, so... Ay, honey, manisit sa... Theorem 1.10. So let A, B, and C be any sets, then ali lang ko sa number 2, ma'am. If A is a subset of B and B is a subset of A, then A is equals to B. So let A is equal to the set of MERC and B C R E M. So since every element of A is in B and every element of B is in A, so we have A is a subset of B and B is a subset of A. So therefore, A is equals